Today we're starting Module 7, and I just want to kind of give you a warning. Module 7 has a whole lot in it, so please make sure, I've divided it over 3 weeks between Thanksgiving and Christmas. Please make sure, number 1, that you finish Module 7 before Christmas break so that you're ready to start Module 8 after Christmas, and that you really take the time to understand it, especially the math at the end. So the very first half of Module 7 is about writing chemical equations, and then the second half puts math on top of it. So please make sure that you really spend time learning both those concepts. There'll be about 6 videos that go with this module. So this is the first one. It's on decomposition reactions. So Apologia defines decomposition reactions as a change. Decomposition reactions change a compound into the elements. So basically a compound breaks down into the elements that make it up. They point this out at the end, and I just want to point out here, this is not the only type of decomposition reaction. There are some decomposition reactions where one compound changes into simpler compounds, not necessarily the elements. But for the practice problems you will be doing, you're going to assume this definition. We're going to take a compound and we're going to break it down into the elements that form it. So here are the steps to writing a decomposition reaction. First, you want to write the compound that you're given, usually in the problem, on the left. Of course, this is the reactant side. Then you'll draw the arrow, and you're going to write the elements that form the compound on the right. And these are the products. And here, I just want to mark this one. Please don't forget it. Don't forget your diatomic elements. Okay, so if you, on the right-hand side, when you write the elements that form the compound, if you write NOF, CL, BRI, or H, all of them need to be written in pairs because they are diatomic, which means that they come in pairs when they're written by themselves. And so on the right-hand side, when they're written as an element by themselves, you will need to include a 2 with those. Please don't forget that really does change how you will balance them. So your final step is balancing. So let's look at 2 examples. These are the ones given in the book, but the book takes like 5 pages to walk through them. So I'm going to try to walk through them a little simpler. Okay, so here's the compound given me, and my task is to write the decomposition reaction. So I'm going to start by writing my compound, C2H6O, on the left, and then an arrow, and now I'm going to look at what elements make up this compound. Okay, the first one is C, so I'm going to write a C. I'm not going to write a 2 because C is not on my diatomic list. Okay, the next element, so then I put a plus sign between them. The next element is H. That makes it up, and I am going to put a 2 here because when H is written by itself, we write a 2. And then my final element is O. And again, O written by itself is 2. I want you to point out there's only one O over here, and that's okay because it's in a compound. The diatomic rule only applies to when it's written as an element by itself. Okay, so this is my base beginning. I took my compound, which was made of C, H, and O, and I broke it apart into C, H, and O, both of these being diatomic. Now my goal is to go back and balance. So this is good practice in balancing as well. Remember, pick one thing to start with, and I would always save H and O for last because they're usually the hardest. So I would start with C here. So I've got 2 C's here, 1 C here. So to get that to be 2, probably should have a pencil, but I'll just mark it out if I need to. I'm going to put a 2. Okay, to start with, I'm going to go ahead and do my H's next, just because they're in order and it doesn't seem to matter if I do H or O next. So over here I have 6 H's, okay, and over here I just have 2, so I'm going to put a 3 here, because 3 times 2 is 6. Alright, then last I'm going to do my O's. Oh, okay, so we can see O, I've got 1 on this side and 2 on this side, so I'm going to have to come back and put a 2 here. Alright, hopefully you realize that messed up my C's and H's, so I'm going to have to start again. No problem. This is just the process we go through. So now let's look at my C's. 2 times 2 is 4. I only have 2 right here, so if you're using a pencil, you can just erase, but that's going to be a 4. And then let's look at my H's. 2 times 6 is 12. This is a 3 times 2 is 6. So to get that to be 12, I need to make that a 6, because 6 times 2 is 12. And then my oxygens are still okay. 2 oxygens, 2 oxygens. So this right here is my balanced decomposition reaction. 2H260 makes 4C, 6H2 plus O2. All right, let's look at one more. SiH3F. So again, begin by writing your compound. on the left, and then you do your arrow, and then you look at the elements that make it up. Okay, Si is my first one, so I'm going to write Si, and I'm not going to write a 2 because it's not diatomic. Then H is my next one. H is diatomic, so I'm going to write a 2. Then F is my last one, and it is diatomic as well, so I'm going to include a 2 there when it's written by itself. Okay, so I've taken my compound. I've said, okay, what are the elements that make it up? Si, H, and F. Si, H, and F. I've taken into account diatomic elements. Now it's time to balance it. I'm going to start with Si. So there's 1 and 1, so I'm good. Now let's look at H. Okay, so I've got 3 H's here and 2 H's here. So that's a little more difficult because I can't just stick like a 1 here and somehow make that 3, because remember, those numbers multiply. So I basically need to find a way to make 3 and 2 equal to the same number. Hopefully you see that the way I can do that is to make them both 6. So if I put a 2 here, 2 times 3 is 6. And if I put a 3 here, 3 times 2 is 6. I want to point out, I have to put this 2 in front of this entire compound. I can't just stick it in front of the H. That H is part of the compound, so any number has to be written in front of the entire compound. Okay, so 2 times 3 is 6. 3 times 2 is 6. At this point, you can do one of two things. You can continue on to your F and then come back to the Si. As you notice, we've messed up our Si now because of this 2. Or you can start again with the Si. I'm going to go ahead and fix my Si because it's pretty easy to fix when it's by itself. This side has 2 Si's now. So I'm going to put a 2 here. All right, now I'm going to check my F's. There's 2 F's here and 2 F's here. So this is my balanced decomposition reaction. 2 Si H3F breaks down into 2 Si plus 3H2 plus F2. All right, hopefully those aren't too hard. Just remember to follow the steps and then always double check your balancing. And we'll talk about the other 2 types of reactions in the next 2 videos.